Okay, now we're going to go into an area called biotechnology, and we're going to look at some of the theories and ideas that are being developed about biotechnology. You should have already started your notes about the areas of technology and got a whole page of notes from those in the first video, but if you haven't done that yet, that's okay. You can go back and do that again later. You should also have a list of notes over biotechnology, and that's what we're going to talk about right now. Now, biotechnology and biology are very, very similar. However, the slight difference is that we're going to use the technology, the computers, and all of the advanced things that we have today to work with biology. So it's very overlapping, very related to each other, slightly different, but we are going to take a little time and explore this. Biotechnology as well as nanotechnology is another area that is brand new, probably been only really going strong in the last 5 or 10 years, and it is an area that they think may soon overtake communications as the #1 technology in our world today. Biotechnology is the study and exploration of improving humans, animals, and plants by combining or enhancing them. As we talked about, it's predicted that this might overtake and have a big impact on our world. Biotechnology can relate to many of the different areas that we've already talked about. Some people have a lot of concerns about this technology. They believe that we are messing with God or messing with nature, and they may well be right. So this is an area that we want to go into very, very carefully. If you perhaps saw the movie I Am Legend, the very first scene in the movie is a lady on TV announcing that she's found, or they've found, a solution to cancer. And the theory behind the movie is that this new cancer-solving drug or whatever it was put right into people. Now, in real life, we try to be much more careful than this, and we'll test on insects and small mammals and then gradually go up to monkeys, which is closely related to man, no offense intended, and then eventually maybe start trying it on man. But we do take a lot of care before putting these things in humans, and obviously that would not have made for a very good movie. However, it is an area that we want to go into very, very carefully. Now, while some people complain about the thought of biotechnology and genetics and different things that we're going to talk about 60% of the food that are in stores now have already been genetically engineered or genetically altered. A couple of the big ones would be corn. If you've ever had corn that has both white and yellow kernels, that is genetically altered. And tomatoes is a greatly altered food that we have. We have green, we have red, we have yellow, we have stripes, we have a variety of different things. And what we're going to talk about in this video is some of the things that they're working on and exploring in the way of changing things and altering them. Scientists found that people have similar DNA to other forms of life. So if we kind of look at some of the statistics, you have about the same DNA as plants. So theoretically, if this is possible, 20% of the DNA in a plant could be in a human or placed in a human, or 20% of the human's DNA could be placed into the plant. We're about 40% compatible DNA genetically with insects, 80% with chickens, and then almost 99% with monkeys. So again, when we go through the process of exploring whether or not a medicine or something is different or going to affect us negatively, we'll go through this process of trying it on insects, and then working our way up before really putting it into people. One of the first things we're going to talk about in biotechnology is hydroponic farming. And hydroponics is the technology of growing plants whose roots are not placed in dirt. So if you printed out the notes, as you should have, what you want to add to those notes is what is in blue on the screen. And that is the definition that you'll see on the test and that you need to know. We'll take these plants and we'll have water and fertilizer, and then we're going to need some kind of solid so the roots can hold on. Otherwise, as the water is flowing through, it would pull the plant through and kill the plants. So we need some way for the plants to be stabilized. Well, what would this look like? If you can imagine having tubes, PVC pipe probably 4 inches in diameter, maybe smaller, coming out of a ceiling, we could put on top of a roof a large thing of water, and in that water we would have fertilizer. And then we'd use gravity to have that water flow down into the first pipe that goes across the ceiling, drop down at one side of the room about 3 feet, go back across the other side of the room, drop down 3 feet, and this little back and forth zigzag across the room would allow plants to be growing from the floor all the way up to the ceiling. Whereas today we only plant things in the ground and we can only do the area, which would be the length times the width. In the future we could probably not only go length times width, but also height, and grow the plants all the way up to the ceiling. So if we had an empty warehouse in downtown Indianapolis, we could theoretically grow these plants 3-4 stories high and provide lots of food. A good example of this is up around 21st Street and 465 about 15 years ago. There was one farm, one house, one family, and a lot of land. Well, that farm's been sold many years ago, and they now have over 150 houses in that area. So we have probably 150 families, and we've lost the area to grow our crops. It's not a problem in Indiana because we still have a lot of farmland around, and we can still do that. But as we continue to grow, this might be something that we need to look at. Or some countries that don't have the room to grow like we do might want to start looking at this already. So once we have these pipes serpentine down the wall, we'd have a little walk space 3 or 4 feet where the workers could go through and harvest the crops, or maybe even if it were 2 stories, take a machine through there. Then we would have another row of pipes, another walk space, another row of pipes, and again, from front to back, from the floor to the ceiling, would be full of plants growing. And then we would have room to move through to harvest the crops also. Once the water gets to the bottom of the pipes, we are going to have some way to pump it back up to the roof. That would require some energy. But again, once it gets to the roof and it gets into that big tank, we add the oxygen, we add fertilizer, and then we use gravity, which is free, to bring that product or that water right back down to the product. Hydroponics could be used in areas where you have poor soil, things don't grow very well. You don't have a lot of open land. The weather is not very good, it's either too cold or too hot. And there's limited rain. We just can't get the water that we need to the plants. I've heard reports that when you're watering your yard in Indiana, about 50% of the water that comes out of the hose evaporates. It doesn't get into the ground that quickly. With hydroponics, we could eliminate that, and the water would be used very effectively. If we were in an area where there was not much water, very little of the water would be lost, and most of it would go directly to the plants. Genetic engineering is another area of biotechnology, and that's manipulating the genes of something to change or control it. Genetics is often used to create identical plants or animals, and we're already doing this in some areas. Once they develop a plant that serves the purpose they need, either the flavor of that plant is exceptional, it grows fast, perhaps it's a flower that has a lot of blooms, has thick blooms on it, whatever it is that they want, once they have that in a plant or an animal, they can then clone that animal to grow more of them, or identical ones. And this is, again, becoming widely used in some areas today. Now, as we're talking about this, we're going to look at some things that are already been done. We're also going to look at some things that they're thinking that they might do in the future. So again, we need to evaluate these things as we go into them and make sure that they're going to be acceptable. For example, if we can create crops or animals that need less water. For example, in Indiana, corn can be affected by dry spells, and it might not grow as well as we need. Well, succulents, which are cactus, have a very deep tap root that goes deep into the ground, and it's going to get a lot of water where other plants nearby don't have access to that water. Corn and many of the plants that we have here in Indiana have a very high root ball, and it's near the surface. So again, when it gets too dry, they lose that water and can die or not grow as fast as we need them to. So if we can combine a cactus or a succulent with the corn and get a deep taproot, would that be a benefit or not? Well, if the stickers that are on cactus develop on the corn ears, obviously that wouldn't be a good idea. But if we can maybe get the taproot, a lot of the cactus have such a deep taproot that if you cut the cactus off, that root will grow back. So let's go to the next one here, growing faster. What if we can create a corn that instead of growing one crop a year, we can create a very fast growing corn? So we could say maybe plant the corn in May, harvest it in June, plant more in June, harvest it in July, plant more in July, harvest it in August, and get 3 to 4 times as many crops as we normally would. Some plants will resist disease and insects and some won't. So if we can take the ones that resist the insects, blend it with the ones that the insects like to eat, can we stop that? Can we prevent that biologically without spraying pesticides on the product that we're wanting to eat? Fat, unfortunately, is what makes food taste good, and it's unfortunately what is harmful for our bodies. So we can get a fat or a less fat meat, but most people do not care for the taste of it. So again, can we create a meat with less fat that has a good flavor, that has a good taste? And again, avoid putting harmful chemicals into that product. These are areas that we want to look and explore and see if it will work. If you look at the farmer on the right, that entire field, I got that picture off the internet, and that entire field has been cloned from the same plant. I don't know what the plant is, but again, whatever the condition in that plant was that was exceptional, the blooming, the density of the flower, the flavor, whatever it is, they can then clone that and they know what they're going to get every time. The same thing is true with the little pigs on the left. For whatever reason, they grow fast, the meat is flavorful, whatever. All of the pigs in that picture have been cloned, and they're clones of the original donor. And again, when we're cloning something, we only need very, very small cells from that donor, so we can grow millions and millions of clones from that one donor without any problem. Here's some examples of things that we've already experimented with. On the upper right are zebrafish, and zebrafish are pretty common fish, about $2 in any aquarium shop. But what they've done is they've taken the bioluminescent gene from a jellyfish and they've figured out a way to put these into the fish. And again, we're not really working towards fish that glow in the dark, but fish, what will it do to them? What will happen to the next generations? One of the things that came out of this is scientists have found that when they release these fish back into the water and they can hold a black light over the top of it, the color of the fish glow will indicate what pollutants are in that water. So perhaps we could do something with this to keep tabs on what kind of pollution is in the waters around our area. We've also done this with grass. They have developed a grass that will glow under a green light. And if you notice the picture on the left, those are 2 baby mice that, again, the bioluminescent gene has been instilled in. If you look at the picture on the right, the mother got the bioluminescent gene, and the scientists wanted to find out, well, will this pass on to each consecutive generation? And they found out, in fact, that it will. Now, if you notice these, the fur does not glow, but the skin will. So the ears, the nose, the tails, the feet, those are the areas that you can see the glow. Another interesting side effect from the fish is they've started selling these glow-in-the-dark fish in fish shops for about 20 times what they originally cost, and they're using that money to help supplement the research that they're doing in the lab. Genetically altering both animals and plants has concerns with how those changes might affect humans. Again, the cow in the upper right is a cloned cow. The ones in the bottom, the watermelon in the bottom, are actually cloned also. This happened in Japan about 8 to 10 years ago, and we have the technology. We could easily put a fruit or some product into a restrictive device. We could restrict that and force them to grow in the shape we want. But that's not the case here. These were actually genetically created to grow square so that they would be more effective in stacking them. They won't roll around in your car as you're driving home. They'll fit better in the truck and they can get more in. And this was genetically created. If you ever think about seedless watermelon, if you don't have seeds for your watermelon, how do you grow more watermelon? And the bottom line is, it's cloned. So if you don't like the thought of cloning, but you've had seedless watermelon, well, you've already taken part in that. And again, the effects might not be known for generations, so we really want to explore this, get as much information as we can before we bring it into the food market. Tissue engineering is not in your notes, but it is a big area, and I do want to spend some time talking about it. And tissue engineering is using created materials to repair or replace injured human tissue. Now, the uniqueness of this is we're using those materials that we're using is actually coming from your skin in some ways. So we can take 1 or 2 cells from your skin and we can create an entire area out of it. So if you look at the picture that just popped up on the screen, here's a few cells of human skin. Within a few hours or a day or two, these can grow into a size of 5 by 5 inches to be replaced where needed. Let me give you an example. If you were to say have a 3rd-degree burn, you've touched something that completely destroyed your skin. You have a 1st-degree burn, which would be like a sunburn. It would be a reddening of the skin. A 2nd-degree burn would be blisters. And then a 3rd-degree burn is the total death of the skin. Well, if this area is fairly large, say several inches, that skin that has had the 3rd-degree burn will not grow back. It's dead. It cannot be saved. Now, if it's a small area, your skin will stretch out and cover that up a little bit. But if it's a fairly large area, that's a problem. Well, in the early days, we would take a section of your skin and we would graft it over the top of the burn. So in a fatty area of your body, the backs of your legs, your waist, or somewhere you have some extra skin, they would take that skin, cut it off, graft it to where the injury occurred. And this was very helpful in small areas. But what if somebody had an injury over, say, 50% of their body? You can't take 50% and put it over the other 50% because you run out of skin. But with today's technology, we can take a few cells, put those cells in a petri dish that looks has a material in it. It looks something like a screen for a screen door. It's not that kind of material, but it looks like it. We put a few cells on there, and within a few hours, those are going to grow and create a 5 by 5 section of skin. And it's your skin, so the body won't reject it. They then place these over your body where needed, and we can save people that have had severe and widespread burns or injuries. We're also exploring ways to do this with nose, ears, and more, and we're going to talk about that on the next slide. This is a Mexican hairless mouse. And this experiment was used to grow a fake human ear. Now you have to understand that the ear on the back of this mouse cannot hear. The hearing part in the ear is inside your head. This is on the outer part. So this just gathers the sound and directs it back into your ear where you can then hear more sound. What they will do with this mouse is they'll inject a small balloon underneath the skin, and they'll gradually increase the size of the balloon to get the skin to stretch. They then will insert a material under the skin that is cartilage-like. Cartilage is the material that's in your nose, it's in your ears. When a person dies, those areas go pretty quickly. They will go about as fast as the skin and the muscles and all the other tissues. They're not going to remain in the body for many, many years like the bones will do. So if you've ever seen a mummy or something like that, you'll notice the nose is empty and hollow, as are the ears. So what they'll do with this then is they could use this if a person were injured. They could again inflate the person's skin, insert one of these under the skin, and once it attaches to the skin, they could then take it off of wherever it is, say the arm or the leg, put it back on the body where it should be, and that person's going to have a fairly normal appearance. I happened to hear one of the first stories about trying this, and it's pretty an interesting story. There was a guy that had cataract surgery, and cataracts are a whitish area that will form over the eyes, and it's like looking at the world through saran wrap. Creates kind of a whitish tint, and things just aren't quite as clear as they normally are. Well, this gentleman had cataract surgery, and months later he planned to climb Mount Everest and try to summit one of the tallest mountains in the world, at least above ground. As the guide and the two guys that were with him started to get near the summit, the change in atmospheric pressure caused this gentleman's cataract surgery to fail, and he was blinded. Fortunately, it was temporarily, but for the entire time he was up that high, he was blind. Well, the other gentleman with him had tried to summit the mountain 10 times and he never got to the top. So the guide decided he was going to pitch a tent, put the guy that was now blind in the tent. They were going to go ahead and summit the mountain. The other two guys would come back down, pick him up, and then escort him down the side of the mountain. The bad news is that the guide and the other guy never made it back. A storm came in and they both died on top of the mountain. The guy that was left in the tent was there for so long without food and water, and he started hallucinating and thinking that he was hearing his family right outside the door in the storm calling for him. And he realized that they weren't coming back, and he decided that he was either going to walk off the mountain and die, or he was going to make it down the mountain, but he wasn't going to remain in the tent and wait. And amazingly enough, he did make it down the mountain safely, but he did lose his ears, his nose, all of his toes, and all of his fingers to frostbite. So what the scientists then did was recreated the nose and the ears for this gentleman by using this method. And that is one of the first uses of this in an actual situation. Ergonomics is also known as bioengineering. And ergonomics is the design of products to be more easily used, safer, and comfortable. If you look at the pictures on the right, some of the problems that we have with the traditional keyboards with the computers is straining the tendons in the wrist. This is called carpal tunnel syndrome. And this started happening from people using these a lot and the awkward angle that they had to set. Many of the people that got this injury then sued the computer makers for the damages that they had and to help them recover. Now at this point you would think that the computer creators would change things, but in actuality the only thing that they did to avoid lawsuits is they will put a warning in their manual that you never ever read that says take frequent breaks and don't sit in this position for long periods of time. So basically the problem is still ongoing. There are some companies that are coming out with a little bit better designed keyboards to help you. So ergonomics is designed to try to get you to have things that are a little bit more comfortable. Some of the common examples, and again you want to put these in your notes. Tools. They're creating tools that are easier to use. More and more women are beginning to use some of the tools that have traditionally been used by men. So they're changing the size of these to make them more adaptable to smaller hands. And we're also developing things to cause less stress on muscles and joints. Kitchen items are also very common. If you look at the mug on the right and the shape of the handle, designed to be more easily grabbed and to grip that little bump in between the fingers to hold on to it a little bit better. If you know any women that go to pampered chef parties, those are very commonly very ergonomically designed. Rakes and shovels, instead of having the natural or the traditional straight handle, they've started creating them with the curved handle you see in the right. This unique angle allows a person to get under the snow to shovel without a lot of bending and lifting, which causes a lot of stress on the back. Hammers, when they're used repeatedly, that vibration goes through the hammer handle into the arm and can cause an injury, what we call tennis elbow, in the elbow of the body. So they're developing some nicer hammers, ergonomic hammers, that actually will have a tuning fork inside the handle, so every time it's struck, that tuning fork will absorb the energy and not affect the user. Bionics is making replacement parts for the human body. Now, we talked about tissue engineering earlier, and that's a little bit different because tissue engineering is using mostly your own tissue. Bionics is putting completely new things into your body. The movie that we probably most relate to would be the one in the upper right, the Terminator series, where Arnold Schwarzenegger is he's actually a robot with an outer body. That's kind of, again, make-believe, and that's not true. We can't do those things, but it is along the lines of what we're going to talk about. If you look at the next picture here, this is an actual picture of a human that, for whatever reason, and I don't know the story behind it, has a spinal injury that they've gone in and replaced with some type of system to at least give that person some mobility. And we're going to look at several examples here and try to explain what bionics might do. This gentleman is a scientist, and that little device that he's holding in his hand is a stent that is placed into the brain to control a hand. Now, this gentleman not only invented it, but he also volunteered to be the first one to try it. And the thought is, if we can get these stents inside the brain to react to the signals from the brain, the electronic signals that the brain has, we might be able to use that to create artificial hands that actually move. Generally, up to about now in history, if somebody were to lose their hand, we'll put on a prosthetic device. And while from a distance it looks good and it looks like a fairly normal hand, once you get up close, it does appear very plastic and artificial. The other problem is it doesn't move at all. So we're looking at trying to figure out ways that an artificial hand could actually be used to pick things up and as fairly normal human body. Now, the other problem is if you have one of these and you shake somebody's hand, you don't want to crush their hand. That's one way to lose a lot of friends. So if you look at the picture below, there's an example of a human being holding a potato chip and the artificial hand holding something as fragile as a potato chip also. Bionics can also replace large body areas. At the right, you have a lady who's had her entire shoulder and hand and arm removed. And they're working again on developing a system that she can somehow use the muscles that are left to control that arm and train herself. This picture is a cochlear device, and this is used for people that, for whatever reason, their brain did not make that connection to the ear and they're born deaf. And rather than remaining deaf for their entire life, they're experimenting with this to get the sound and then take that sound and bypass the part of the brain that's not working right and take that sound straight to the part of the brain that can analyze it and interpret it. We have a lot of students in Wayne Township that have things similar to this, and they're very effective. And as we get better technology, perhaps someday this will actually be very small and under the skin to where nobody will ever see it, and that person will have a pretty normal situation. Bionics can also be used to enhance the entire body. This is a bionic suit to add strength. So firefighters going into a burning building that can't lift the person inside, by putting or donning this bionic suit, that would allow them to lift a heavy person. Or construction workers that need to lift a very heavy table or a cabinet or several bags of cement could use this to help them do a better, more effective job. So actually these people in the pictures are normal, they have no physical handicaps, but the bodysuit will give them extra strength. Bionics may be electronic or simply add-on, as the case of the runner on the right who lost his feet and still had a desire to run. They developed a spring-like mechanism that attaches to the feet, because with prosthetics, as you run, they're very rigid and you don't get that bounce that you get in the normal body. So you have to develop a system that's going to bounce and spring as you run. And this is what scientists have currently been working on. They actually had, and I don't know if it is this person or not, but they had a person a few years ago petition to be allowed to try out for the Olympic team. But the Olympic Committee wanted to explore it carefully And if these add-ons would give that person an unfair advantage, they didn't want them to compete in the Olympics. They did rule that it was not an unfair advantage. They did allow this individual to try out for the Olympics, but unfortunately he did not have the speed to qualify. But it is a start. It is something that's changing our society. And I hope as we go through this, if there's something that you don't get or I go too fast, that you'll stop your video and get the information that you want. I also want you to know what biologically inert means. And when we put something, a material in the body, if it's not from that body, in other words, if it's not your own tissue, sometimes the body will reject it. So materials that being placed in the body cannot be made of something that the body will reject. And that's what we call biologically inert. If it does reject it, if the body does reject it, this can cause massive infection that can actually kill the person. When we had early heart transplants back in the 70s, they didn't die from the heart. They died from the infection of the body fighting that material that was put in to replace the heart. And some of those people that have things put in like this have to take a medicine to keep their body from fighting that for the rest of their lives. So again, as we explore this, we want to find ways that we can use things that will not cause this infection. And again, the picture that just showed up on the screen is the stent that the scientist put into his brain to try to operate a mechanical hand. Biometrics is a really big area, and I think this is going to impact us very, very quickly. Biometrics is using technology for body recognition. And what that means is that your body is going to be recognized, or a machine rather, will recognize you by parts of your body. And this is already in place in some areas. For example, many banks, the people that work in the banks work with so much money that they don't want an unauthorized person to come up and use the computer. So these banks will have a computer that recognizes the fingerprint of the person that works there. And if that person's away for more than 10 minutes, the computer will shut down or turn off. That person has to be rescanned and re-recognized by the machine. Cruise lines now are, when they take your picture when you get on the cruise, they'll store those into the computer. When you get back on the boat after getting off somewhere for a little trip, they will scan your face again. They usually will have cameras there, scan you and recognize you and compare you to the picture that they have previously. Military people, one of the problems, and this is also true with police officers, a criminal could take, or the enemy could take that gun and turn it on you. So they're developing weapons that will only recognize the person that's programmed to operate it. So if the military is in a battle, the enemy overtakes them and overpowers them and turns their own weapon on them, it will not work, and that person could possibly have the opportunity to escape. The big holdup for a number of years with biometrics is the massive amount of memory that's needed to recognize all of these different things. For example, a voice. You will notice my voice, I have a little bit of a lisp, and some words I struggle with a little bit. Or I might be from the South, or I might be from Canada, where I have a heavy accent. We've got to be able to develop programs that can store enough memory that can recognize a variety of different intonations and words. And we are starting to get to that. We're starting to get to the memory level now when we're getting into gigabytes and now terabytes and having tremendous amounts of memory that we can start doing activities related to biometrics. And I think this is an area that's going to really take off. What biometrics will do is it will use your voice, your fingers, or your hand, your eye, or your face to replace all of your keys, all of your credit cards, your locks, and everything else when you check out at the grocery store. Quite feasibly, we will no longer be a society that uses money. We'll still have that value, and we'll still have the backing of the government into the value of that, but much of the money is going to be electronically debited and credited. Credit cards won't be used because it's going to be automatically recognize your body. The keys to your car or the keys to your house won't be necessary because as you walk up to the door, the house is going to scan you, it's going to recognize you, and it's going to unlock the door for you. Now, students in my class always come up with just a ton of problems that this could create, and they're absolutely right. There are a lot of problems that we need to solve before we can do this, and those are things that we're going to work on. Again, as we talked about at the very beginning, technology is both good and bad. There are going to be problems, and technology is constantly changing. So once we find a problem, we'll have to figure out a technology to fix that problem. Let's take a look at the schools of the future. What could possibly happen with all of the biometrics that we're talking about today? Well, one of the first things that we probably see is no textbooks, no books to carry around, no paper. You don't need to bring any paper to class. Some schools are already experimenting with this. They're using the iPod or the iPads and getting rid of their textbooks altogether. Now, that's been going on in a couple schools for a year or two, but one of the problems they found is that there are people out there that are stealing the iPads. Sorry, I'm old. I keep forgetting. So we need to figure out a way how to stop that. But I would not be surprised within just a few years where books are replaced. The teacher will no longer have to take attendance. As soon as the student sits at their table, they will be recognized and attendance would be taken. There actually was something here in the year 2012 in the paper recently where they're working on a seat that will recognize the driver of the vehicle by their butt. So we're actually going to have a butt scan for cars of the future. They said that everybody's butt is different and we all sit differently. I personally don't go around looking at everybody's butt, so I wouldn't know about that. Pencils, if we don't have books and paper, we don't need pencils and pens. We don't need passes anymore because the computer will track you. If you get up and leave the room to go somewhere, the entire building can track where you're going and permit you or unauthorize you to go to a certain area. Theft and intimidation, as soon as your body starts to feel that stress, and it's very well indicated that situations like that, either from the person that's intimidating or the person that's being intimidated, their bodies react to that. Well, the sensors in the building can check that out, immediately turn all the cameras on the situation, immediately contact the authorities, and you can't very well come up with an excuse because it's all on videotape. Teachers might become very, very limited in their use. The teachers could eventually become more of a helper and less of a secretary. And you would be more responsible, or the students. It won't happen to you guys, so you don't have to worry about it. But they'll be more responsible for helping out instead of keeping track of everything. Lockers, we might not ever need again. And combinations we can get rid of. You walk up to your locker, you look at it, it recognizes your eye, and it opens up for you. One of the things that's been experimented with a lot recently is limited hours. If you're a good, outstanding student and you get your work done quickly, why should you have to hang around and wait for the others? So one of the things that Indiana's looking at right now, and one of the reasons why we have this online teaching that we're created, is because they want by the next year or two to have every student required to take 1 or 2 classes of online education. A lot of the colleges have already gone to this. So you need to get that experience of what online education is about. For example, out west a few years ago, they were running into a lot of problems with the cost of gas and operating the transportation systems out there and the cost of running the school. So what they determined was they were going to shorten the school week to 4 hours, or 4 days, sorry, nice try. 4 days and try something a little bit different. So the students would go from Monday to Thursday for the whole day. Then on Friday, all of the students that had C's or better got to stay home Friday and have a 3-day weekend. Students that needed extra help would have to be transported into the school, and the class sizes would be much smaller, and that would help the teachers help the students, and then we would reward the students that were doing good. And as students got better, then they would get that freedom to have the day off. Now the bad news about this is that when you have that Friday off, you would still have assignments and work to do. And you might do that work all Friday morning and be done for the rest of the weekend. You might do it a little bit each day. You might wait until Sunday at night and cram it in together real quickly. We won't have to waste time. We won't hide grades because the grades would be immediately graded, immediately sent to the parents, and everybody would be aware of it. You couldn't fake an illness. You couldn't fake having to go to the clinic. The room or the building would scan you, analyze your temperature, analyze your body signals, and would recognize that yes, you do need to go to the clinic, or you do need to go to the bathroom, or no, this is just another little idea to get out of the classroom. And then lost homework would be a thing of the past. It's all going to be tracked. So again, there's some good and there's some bad. Perhaps the game systems of the future will look more like this. Instead of setting across the room, you would actually have 3 screens in the front of you that would give you a pretty much side-to-side view. And your chair would automatically move and rotate in rhythm with the game that you're playing. For example, if you were playing Star Wars and you're flying through the sky attacking the enemy, your chair would actually move with you. Somebody comes to the door. When the doorbell rings, it comes up on your screen. You can see who it is. Press a button to unlock the door or ignore them completely. Phone call comes in, and many people already have this today on their televisions. It will tell you who's calling, and you then have the option to answer or hide.